Yeah, so weather lens. So welcome today. So I'm excited to introduce our project, which is weather lens. So in a world where accessing accurate weather information is critical, so our weather lens provides time to time updates on weather changes that impacts our daily lives, from agriculture, business, those areas mainly impacts. And when we talk about the concepts and the design of the weather lens, we have differentiate the we differentiate into three: backend framework, database management, and the front-end development. So when you talk about the UML design, the UML diagram illustrates the mapping between users, the single page application, backend system, and the database, showing case how real-time weather data is presented to users. Yeah, when you talk about the user interface, I have divided into two screens, which is home screen and the map view. When we go to the home screen, you have to scroll up to see the map view. Then you can see the updated map view. Yeah, this is the technical discussion. So currently you can see the weather data API endpoints, which is the backend. You can see here validate API key. It is validating the headers from passing from the front end. So I'm passing the API key. It is validating from here, and I have limited the response into 25 and sort the response from the timestamp, which is the time date. And this is the front end fetch weather data. So I have used here use effect and map box, which is I have used the package to show the map, and I have given the map access token, and every 1 minute it will update the set weather data state. So I have set the interval time, which is 6,000 milliseconds, which is 60 seconds, which is every 1 minute it will update the set weather data and show the users the current weather informations. So yeah, when we talk about the data generator, this is the data generator. So I have used district object, which is a hard-coded object. So I am like randomly generating temperature, humidity, and the air pressure. Those randomly generated fields, and I have assigned to the constant variable and passing to insert weather data, which function will insert to my document. So yeah, when we talk about the server deployments, so I have used a platform called render.com, which is a free platform. We can easily sign in with our GitHub accounts. We can choose our repositories and easily deploy. And there's a feature called you can deploy latest commit, which means it can identify last commit. So it will work sort of like CI/CD pipelines. Yeah, that's it for the weather lens web application. Thank you. Hello. So yeah, I'm going to explain about the weather lens web application, which is implemented with the React.js and for the backend Node.js. So I'm going to demonstrate the code wise first. So yeah, this is the code wise. So I have differentiated into three folders: backend, frontend, and the weather station. So I'm going to demonstrate the backend first. Inside the backend, there's a folder called models. Inside the model, there's a file called weather data, which is the schema I have defined for the mongoose, and which is the collection attributes. Here you can see district, latitude, longitude, temperature, and humidity, air pressure, and this is the MongoDB collection attributes. And here you can see the server.js, where the API is written. Inside here I have used these packages: Express, Course, Mongoose, Swagger.js, and Swagger UI. So inside here you can see whether I have imported the weather data schema from here, and I've used Express as well. In the main function, this is the route. This is the route. So in the route you can clearly see validate API call, which is passing a header API key, which is hard coded for now because we don't use a login authentication for now. So I have hard coded a key from the front end and the back end, and I'm passing the key from the front end as well to check here. Whenever it's calling the route, it is checking the API headers and the key in here. And I have limited the 25 limited the data amount. Here it is retrieving the latest weather data. Yeah, so this is the backend, and this is the Swagger implementation, and I can explain the front end now. Yeah, so when it comes to front end, inside the app.js, I have created a show map boolean state to scroll. When it scroll only, it will call the weather map component. Inside the weather map component, I have used this package Mapbox, which is a free package to show the map. Inside there are more features in the Mapbox. Here we can define the Mapbox styles, standard, streets, light, dark, those styles, and I have created these states to set the weather data fetching from the backend. So this is the use effect. Inside the use effect, I'm giving the access token to the Mapbox. In here, I'm fetching the map data. I'm setting the fetch data to my state, and here you can clearly see I have defined set up an interval to fetch weather data periodically. It is every 60 seconds, every 1 minute, it will call the API and set my state. Here you can see the API call. This is the endpoint which I deployed my backend in the cloud, and this is the API key. So like I mentioned before, I have hard coded the API key and passing as a header to the backend and getting the response. Yeah. So here inside the state, I'm setting the data like this. I'm accessing the data.district and the temperature and the humidity and the air pressure. Yeah, so this is the front end. So I'm going to explain the weather station, which is a data generator. Here you can clearly see I have created an object called districts, and hard coded these values, and inside the main function you can see there's two modes, which is demo and the station. When it when it call when it gives demo, which will automatically generate the data, and there's an option called station. When it gives station, manually data manually can entry data can enter inside the generate demo data. I have getting that client. I have getting that DB connections and the collections, and I have randomly generating these values and storing into constant variables in the district array, and I'm passing the insert weather data, this array and this object, and these randomly generated values inside the insert weather data. You can see I'm getting those DB collection and the backup collection. I have created the backup collection as well to store the backup data. So yeah, inside here, firstly I'm creating a document and inserting to my collection first, and the backup collection as well. So this is the data generator, and there's a option called manual data entry as well, which is the same, but we can give the data manually. So I'm going to start the server now. Start the node weather station now. So I'm going to choose the demo. So it will start generating demo data for all districts. So it will inserting data to Ampara every 25 districts. It will generating data and inserting to my collection. Every time inserting, giving a log here. Yeah, it will insert. So while inserting, I can demonstrate the deployment. So yeah, I have for the deployment I have used render.com, which is a free platform. We can sign in through our GitHub accounts. So here you can clearly see I have deployed my weather lens, which is the front end, and the weather app is the back end. So I can show the weather app. Here it is identifying, we can give the repository, and it is identifying the last commit, and we can deploy the latest commit as well in last commit. So I think the data is inserted, still inserting. So it is inserted. It is waiting 5 minutes until the next update. So here I have forgot to mention that here every 5 minutes I'm generating the data and inserting. Here you can see I have set up the timeout 3 lakhs milliseconds, which means 5 minutes. I'm setting a time up. So every 5 minutes, after 5 minutes, it is inserting the data. So yeah. So I'm going to demonstrate the front UI wise. So this is the home page, which I need to scroll to the map view. When I scroll, it will start fetching the data, and you can see the generated data is here. Data are here. Zoom in here. Clearly you can see Hambantota and template goal, culture, Colombo, temperature, humidity, and the air pressure. Those things it is fetching. So I can show you the network call here, and I have console log the data here after fetching. The network call. I'm going to refresh again. When I scroll here, the API call is going, and every 60 seconds, every after 1 minute, it will call a weather API. It will call my API and update the latest weather data. Yeah, so these are the updated weather data. Yeah, and inside, so I'm going to explain the DB wise now. This is the weather DB. I have used MongoDB. So here I have created two collections, which is backup weather data and weather data. Inside the weather data collection, this is the updated, lastly updated generated data is stored here. So inside the backup, here you can see literally there are 2500 documents in the backup. In the updated weather data, it is only 25. Lastly updated weather data is only stored. Yeah, that's it. So here you can see I have implemented these map styles. You can click here, streets, to change the map style. You can select the dark mode as well. This feature is giving us from the Mapbox package here. This is the OpenStreetMap box package. Yeah, standard. Okay, yeah, thank you. That's it.